Okay, let's see how to use AMBIA. To run AMBIA, what you can do is either open the command prompt, navigate to the desired folder, and then run AMBIA, or easier it would be to navigate to the folder where you have installed AMBIA using the File Explorer. So for example, I've installed AMBIA here, and then go inside the AMBIA folder in MB folder, and then click on the SRC folder. So once we are inside the SRC folder, click here in the top address bar and type cmd, press enter, and command prompt will open automatically in this path. And this is the path you should be running AMBIA in. And by running the command python main.py, I can start AMBIA. In the next video, I will also show you how to create a desktop icon so that you don't have to go through these steps. You can just click on the icon and run AMBIA. So AMBIA is running now, and I will explain different parts. It's designed to be really easy to understand and user-friendly, but just to go through all the sections. So on the top bar, you have like a timeline, how AMBIA goes through different steps, and each of these are a module for themselves. So first we have like the loading and section detection, then we have the no-run detection, then we have atlas selection, registration, and final analysis. And we will go step by step. And anytime you are, for example, at this stage, you can always come back by clicking on this stage and move through different stages. Here on the left side, usually you have instructions on how to use that certain stage. And at the bottom, we have the footer where you can view the slide name, the section number, also the color of the footer. If it's blue, this is the normal state, but if it's running something and you should wait, then it turns orange, okay? So if it's in orange, you know you have to wait. So the first stage is loading a slide. And as it says also here, at the moment, AMBIA only supports Mirax and CZI format, but soon, very soon, we will have support for TIFF format as well. So let's load the slide. I have my slides in this folder. I will load this slide. One thing that is really important about loading a slide is that your slides should be named always in a certain format. So for example, a similar format like a letter, a number underscore, a letter, a number underscore, and then again a letter and number. The first letter and number, which starts with A, this indicates the animal, for example, that you are working on, or the experiment that you're working on. The second one can be, for example, the rack that you are, so for example, you have a rack of slides, you have these for a certain experiment. And the third number is the slide number, okay? So maybe you have a big experiment, then you have some racks, and then each rack has slide 1, slide 2, slide 3. And this is the format that you should name them in, otherwise it will give you an error. So you should have 2 underscore, and in between each underscore you should have a letter and a number. I will also show later how this affects the final report that is exported for you. So let's choose this slide. So now the slide is loaded and automatically different sections are detected. Also note that on your version, there might be a detect button here as well, and after you load the slide you have to click the detect button in order for these sections to be detected, and you select this and then you click select. So depending on your version, this might vary. You can now choose which section you want to proceed your analysis with. So for example, I choose this one, section number 4. Now note that down here it says section 4 is selected. You can see the slide name. After I click select, I will also have the option to make a bit of a rotation here. For most slides, you can just leave it as it is. But for some slides, the rotation is so severe that it really affects the registration stage. As you experiment more with different slides, you will know. Usually a few degrees of rotation is fine. You don't have to adjust. But if it's more than 10, 15, 20 degrees, it's better to adjust it. So both ways, if you adjust it and you don't adjust it, you click this cross close button. After you click close, then you have to wait a bit because on the background, it's extracting PNG files on different levels. And this might take a while depending on your system. And you see, as I mentioned, while it's orange, this means you should wait. So now we move to the neuron detection stage. You can see the flag is here now. This one is checked. The flag is here. As always, you have some instructions here. Here you can see your section. You can also zoom in and zoom out to see different sections of it much closer. I will show you later how you can increase the brightness and the contrast to see the slide better. But let's for now just focus on the cell detection. Let's say your slide has only blue and green channel. On the left side, you can see that for the first channel, which is the blue one, you have 3 methods of cell detection. Rabies method is usually good if your staining method is using rabies. For example, your whole cell is visible with the dendrites and everything. But as the name suggests, CFOS is better when you have really the nuclei visible and you have small CFOS-like cells. So let's choose CFOS. MOG is not implemented yet. We will give an update on the website if we have a new cell detection method. But for now, we have rabies and CFOS. For rabies, you have 2 parameters you can adjust. One is the minimum size of the cell you want to adjust. The other one is the threshold, where you can adjust and see which parameter responds better to your slide. But let's go for CFOS. For the blue channel, as we can see, it looks a bit more like CFOS. And for the CFOS, we have 4 parameters. Again, the minimum size of the CFOS you want to detect, let's have this 5. The maximum size, let's give this a 9. Then you can adjust background intensity. You can play around with the background intensity. It can be anywhere between 0 to 255, but try to find the range that works best for you. Maybe it's 10, maybe it's 12, maybe it's 50, but try to find the best value for this one. But for the cell intensity, stick with number 2. Increase it only with increments of 0.1. So either go to 2.1, 2.2, 2.3. This indicates what level of intensity do you want to be detected. So the lower the number, it detects dimmer cells and it detects more cells. But if you make a higher value, it detects only the brighter cells, but then it's much faster. So it depends on you. Let's stick with 2. And for the green channel, since we don't have anything, I think, so just imagine these are rabies, although they're not. Just imagine these are rabies. So let's pick rabies for channel 2. And for minimum size, I put 5 again. And for threshold, I put 50. And then I click apply. So down here, it says, wait, neuron detection is running. And it's orange. So while this is running, I just show you something about where the information of the analysis or the results are being stored. So as I mentioned in the previous video, we have a processed folder in the AMBIA folder where you have installed AMBIA. If you go inside the processed folder, then you can see a folder named the same as the name of the slide you loaded. And this folder is then automatically created. Inside you have S4, which stands for section 4, because we selected section 4 and we have only analyzed section 4 so far. And you can see an overview of the slide that you had. If I go inside the S4 folder, let me make it large. Okay, these are some of the images that are stored while analyzing this slide. So for example, the grayscale image that is created for each channel, and you can see the name of each channel. So this is one channel, this is Alexa Flow 5941 channel, and DAPI, the other channel. As the analysis goes forward, more files are saved here, and I will show you in each step how that might look like. Okay, now it says neuron detection is done. If I zoom in a little bit, you can see some of the blue CFOS is detected, but also a lot of false positive is detected. And for the green channel, we have these 4 detected. So let's say if they are rabies, it's good that these are detected. But then if you have now too many false positives, then you can start playing around with these parameters. Maybe the intensity is too low, you can increase it. Or increase the cell intensity. These are two things that you can increase to get rid of the false positives. So that really depends on you and your slides, because for every slide it's different. But here you can see for the first channel the number of detected cells or neurons, and for the second channel the detected number of cells and neurons. And it also detects the co-localized. So if you want to detect if channel 1 and 2 or the blue and green channel have co-localization, it also detects them. In this case, we have 0 co-localization, but if a co-localization occurs, it shows it in yellow and it also counts it here. But one other thing that you can do here in this window, if you have, for example, something that is wrongly detected, you can remove it. So for example, I can right click to activate editing mode. If you see the cross, it means the editing mode is activated now. And let's say I have here a cell that is not detected. What I can do is, after clicking the right mouse button to go in the editing mode, I can left click to add it to detected cells. And if I want to delete a detected cell, I can simply hold Alt and then click on it. This will remove that detected cell. Of course, if you have a lot of detected cells, it doesn't make sense to do it manually. You have to do it through changing the parameters. But if you want to change like a few detected cells, this is a handy way to do it. And to switch between different selections of colors, you can press Shift. This will alternate between green, blue, and yellow. Okay. So let's say you're happy with this selection. I will change these parameters a bit to have less cells detected, just so we have less computation for the sake of this tutorial. Okay, good. So instead of 20,000, we have 5,000, and it seems a bit more accurate since we don't have all the false positives here, and we see it's detected more accurately. Let's just go with that. So now, if I'm happy with the detection, I click accept. Also note that we have a flip button here. Sometimes, for example, your injection site is on the right, and sometimes you see on the glass slide, the mouse brain was flipped. You can use this flip button to flip it so that all of your slides are on the right direction. But let's say everything is fine and we want to click accept. Now, this is the part where we arrive at the registration stage. This is automatically set to adult mouse brain atlases. So you can select which atlas number it is based on the Allen atlas numberings. Let's say I choose atlas number 56 and I click apply. So now I can see my section image here. I can see the atlas image here. Now I can click register so that automatic registration can start, because I have toggled auto registration on. The auto registration stage uses the Ardent package, as you can also read about it in the publication. And this might take 30 to 40 seconds, again, depending on your system, depending on what level of magnification you have chosen. I will talk about these a bit later. But while this status bar here is orange, you need to wait. Also, if you click on the command prompt, you can see the iterations. So it's now 50 out of 100, it's now 60. So if you're bored and you want to see the progress, you can see it here. And keep in mind that this command prompt is always open while you're running AMBIA, so don't close it. Some important information sometimes show up there. I will show you also later what information could be useful for you to keep an eye on. All right, the registration is now done. It took 52 seconds to register this. But as I mentioned, I'm on a virtual Windows machine. It's not as strong. So depending on your system, it can go faster. Now, in this stage, which is we are here now, you can see they fairly registered well together. You can use this scroll bar here to change the opacity of the atlas in relation to the section image so that you can really compare them. In this case, AMBIA deforms or registers the section to the atlas, okay? So let's say I'm happy with the overall registration, but I would like this part to register a bit better. what I can do is I can go back to the atlas selection stage and select a few landmarks. So again, if I right click, the mode changes to edit mode. You can see the mouse cursor turned into a cross, and I can select, for example, 3 landmarks here, and I should do exactly the corresponding landmarks on the atlas with the same order. So I'm just going to go with 3 landmarks. Let's also choose one here. And then I can click register again. This time it will be much faster because it's not doing the automatic registration, it's doing the fine tuning. And you can see now these parts are much better aligned with the atlas, okay? So now I would say I'm happy with it because I'm not an expert in mouse brain. You're the expert, you can adjust it even more. And then I click accept now that I'm happy with the registration, and we wait for the report to be generated. So now the analysis is done. You can see detected neurons depicted on the atlas, and you can see how they are distributed in different brain regions. But other than the visual representation, you have this detailed report of how many cells fall within each brain region, and it's divided between right and left hemisphere. So for example, for channel 0, which is DAPI, first channel is DAPI, we have in total 5,204 detected neurons, which in the MO region in the right side, we have 165. In the MO region on the left side, we have 271, and so on for different regions, for the other regions. And for the second channel, which is Alexaflor 488, we have in total 241 detected neurons. And this is the detailed report for each region and for the third channel. And we have no colocalization. So please keep in mind that this shows 0, 1, and 2 because in Python, the numbers generally start from 0, not from 1. So know that channel 0 is actually channel 1 and channel 1 is channel 2. So add it up by 1. But where else can you find the report? So if you come in the processed folder inside the slide that you analyzed, and S4 is the section 4 that we analyzed, you see a bunch of images which are related to all the analysis that you've done. The most important ones is the different channel images. You have the source image, which is the image before you did the registration. Then you have the final registered image, which is after it was registered. You see how it's deformed to match the atlas. And then you have this image with all the detected neurons annotated on the atlas or depicted on the atlas. But the most important file here is these 2 report files, which are an Excel file. Let's open these and see what they are. So the report file that you find in the section folder is the detailed report in an Excel format. So these are the numbers that I told you about, that it's important in the naming format of your slide. The name of our slides was A1 R21, so it's experiment 1. For example, you can name these as you want. So this is rack or animal 29, and then it's slide 2, and this is section 4 because we analyzed section 4. And then here we have the name of the channels. We had channel DAPI, we had Alexaflor, we had Alexaflor 488 and 594. And in the next column, we have the total number of detected neurons for each channel. And then we have the detailed report for each region, for each channel. Please note that if you choose CFO cell detection for a channel, 2 more rows appear underneath, which the first one gives you the area of that brain region. So for example, MOP, brain region, has an area of 2,100. This is in pixels. And then it calculates for you, based on the number of the cells detected and the area, the density of the, for example, CFOS cells in that brain region, which can be helpful for some analysis. And if you have selected for the colocalization to be calculated, then you can see the numbers in this room. So this is report in really detailed regions, but you have also this other Excel report, which is report low. This is also a report of the analysis, But this is more coarse, so the regions are not as detailed. So these are level 4. So if you see in the hierarchy of Allen Institute brain region organization, you can see now these are not as detailed. So this is level 4 in the levels of how detailed the subregions are. So if this works better for you, you can work with this one. Now I want to quickly analyze another section because I want to show you also something else. This time I chose section number 2 from the same slide and I went through with the analysis. Now if you have a look at the slide folder, now I have 2 folders for section 2 and section 4, but I also have a report in the main folder of the slide. If I open this report, this is now a report of the whole slide, not just one section. So if you go in the section folder, you will have the section report. If you are in the main slide folder, you have the whole slide report, which shows you that the experiment number is still 1 because we have the same slide, the animal number is the same. The slide number is the same, but now the section number is different for these rows. So we have section number 4, then section number 2, and for these we have different numbers, and you have the analysis of the whole slide and the rest is the same. So let me quickly show you something about the terminal which can be useful for you. While you're running the analysis, you might notice some things are being printed in the terminal. It shows you it's the CZI format, then the name of the channels. I might try to make this less cluttered. So only useful information remain, but you can see name of channels. It shows you with the order that AMBIA knows your slides. The first channel is DAPI, the second channel is Alexaflor 4A8, and the third channel is Alexaflor 594. And this would be 0, 1, 2. Okay, this would be useful for you later on, where you have to adjust a file called static switches, where contains most of the important parameters you need to fine-tune to best fit your slides and your experiment. So remember this one, where you can see this information to see with what order the channels are arranged in AMBIA's view. The rest should not matter much. You just can see how long each section took, and here you can see it's analyzing channel 0 as CFOS, analyzing channel 1 with rabies method, and channel 2 also as rabies method. R stands for rabies, C stands for CFOS. And you can see what color each channel is depicted in, and then the registration. So one thing that is really important before you start using AMBIA is this switches static file here. Because as I mentioned, it has a lot of parameters that you have to adjust based on your needs. If you open it with a notebook or a text editor, you can see what's inside, but it's a lot to cover, and I will cover all these in the next video, as well as I will share some tips and tricks on how to best use AMBIA so the most optimized workflow. I think it's enough for this video, and for now you're good to go to use it and try it out. In the next video I will share more details how to fine-tune it, how to adjust it for your slides.